In binary operation, there are certain hidden facts which we need to understand, and we'll understand it by the means of questions. So, how many number of binary operations are possible on a set A? This is equal to n to the power n square. How we are getting it? We'll try to find out also. We'll try to understand with an example. So let us say we have a set A, 1, 2, 3. We have to find the number of binary operations on A. Before going to this, let me give you a background. We have a set A and we have a set B. Let us say A has 3 values, 1, 2, 3. B has 2 values, 4 and 5. Okay. So B has 2 elements, A has 3 elements. So how many number of binary operations are possible? 2 to the power 3. So this is A is the domain and B is the codomain. I am not talking as a range. So codomain to the power domain is the actual number of operations possible. In order to find out the number of binary operations possible, we'll use the same logic. That is, when we represent A cross A, you remember this star, colon, A cross A, arrow A. What does it mean? The first value is taken from the same set. The second value is also taken from the same set. So there will be a Cartesian product, A cross A. Now here let us say we have A set has n element. The result also should have this n value. Okay. So when we have A cross A, that is we have a Cartesian product n cross n. Because the both A and A, that is the A cross B, should come from the A cross A, that is the Cartesian product. So n square, n into n is n square. So n square are the possible values of the domain. How about the codomain? It is n because A has n element. So as I said, codomain to the power domain. So you have codomain as n and the n square is the domain value. So n to the power n square. That is how it is formed. Now let us try to actually find out the actual value. So we have a set A, which is 1, 2, 3. Okay. So we have 3 elements here. Number of element is 3. What is the formula? N to the power n squared. So 3 to the power 3 square. What is this? 3 square is 9. So it is 3 to the power 9. So I'm just trying to tell you how we got to the formula n to the power n square. And this is how value are found. I hope you will be able to find out 3 to the power 9. So this is the whole idea of number of operations which are possible on any set A. Show that the division is not a binary operation in n nor subtraction in n. N is a natural number. Natural number are the counting numbers. Okay. So we have to show that it is not a binary operation in n and neither on subtraction. So natural number is our set. As I said, these are the counting numbers. So it doesn't start with 0. It will always start with 1, 1, 2, 3 and it goes up to infinity. Natural number always go up to infinity. So 1, 2, 3 like that. So we will pick one value from this natural number set, other value also from the natural number set. That is, we are taking A from this set, B from this set. Okay. So we are taking A from this set, B from this set, and whenever the operation will be there, the final value will also belong to this set if it is a binary operation. So first we'll take the division. So A star A should give you A, that is n cross n should give you n. One value we are taking from natural number, other also from the natural number, third has to be belonging to the natural number. We are going to check it. So when we take the division, it may not be possible. Okay. That is, we are taking the first value and the second value, the bi value, that is the binary. And when we operate it using a division operator, that is n is 1, 2, 3. So if you take A as say 5, I'm just taking random value. You can also pick any random value. So I'm taking A as 5 and B as 3. You can also take A as 3 and B as 5. You will prove it here also. What about A cross B? Cross, I'm saying we have to check for division. So A divided by B. The operation is division. So A division B, that is 5 division 3 is going to give you, which is divide 3. 3 ones are 3 and you get 2. This is 20, 3 is 6. So 1.666 it will come. So you get a decimal value, which is not a natural number. So the division is not a binary operation in n. Second case, we will check for the subtraction. So same operation we are going to do, same thing. But here A cross B, which is the A operation of B, in the case of operation, we are going to take a negative value, minus A minus B. Okay. So n is 1, 2, 3, 4, 5, 6. Any value you take, we are taking the natural number because the question is also asking about the natural number. A minus B. A I am taking as 3, B as 2. So 3 minus 2 is 1. It belongs to natural number. But let us reverse this. Let us take 3 and 5 again. 3 minus 5 is negative 2. Negative 2 is not belonging to natural number. Are all binary operation closed? First of all, you have to understand what is close. Close means it has to follow the closure property. That is, the value when operated, the final value should also go to the same set, come from the same set. Is it possible? Many sets which we are familiar, they are closed under binary operation. Certain may not be. For example, I am taking a set and I am saying that this set is a set of odd integers. Not integers, odd integers. That is those values which are not divisible by 2. So let me make it as a proper set. I'm just crossing it because I have to include the negative value also. So negative 5, negative 3, negative 1 and then 0, 1, 3, 5 like this. This is the set of the odd integers. So when we do the multiplication, say 5 into 3, you get 15. 15 will lie here in the same set because 15 is an odd number. What about addition? For multiplication, this closure property holds. But when we change the operation 3 into 5 to 3 plus 5, and it is going to be 8. And you know what is 8? 8 is not an odd number. It is an even integer. So the binary operation are not always closed. Is square root a binary operation? The binary operation means by. By means there has to be two operands. Unary means only one operand is or one value is required. Because if you are writing a plus b, a and b are two values, a minus b, a into b. So there the plus minus division only works on two values. So that is binary operation. But what if I take under root a, under root b? I'm not using two values, only one value. Under root a is only one value. So a non-binary operation, as I said, where we require a non-binary require one number. Binary should always have two numbers. So this addition, subtraction, multiplication, division, these are the binary operation. But this under root or the factorials, these are not the binary. They are unary operation. For example, the factorial of 3. 3 into 2 into 1. We just need 3. We don't need two values. So factorial of a, factorial of b, factorial of so under root of 36. These are all unary operation. What is the identity element in a binary operation? Identity element is that value from the set when we apply the or when we operate it with certain value, that value should come. I'm saying a set is A. We have some A or B value we have picked up from the set. The E is the identity element. When we apply, A should come, B should come. That is the same value should come back. Or there will be no change to the actual value when it is operated on an identity element. Identity element is, it is a mirror. It will show the same value. So an identity element or a neutral element also we call it as is a binary operation, and it refers to a special kind of element of a set with regards to the binary operation on that set that leaves an element of the set unaffected without any change when combined with it, when operated on it. Because if you take 2 multiplied by 1, you get 2 again. So 1 is the identity. You multiply 3 with 1, you get 3. So 1 is the identity element. Okay, this is all about this discussion. Thank you so much. Take care of yourself.